Hello there guys. In this video we are going to talk about this question. The description is pretty straightforward. The question is about sorting the given array, and the input array has three distinct values. These values are 0, 1 and 2. The question doesn't want us to return anything. It asks to change the input. I will share three different solutions. If this question is asked in your interview, you can mention the approach and their advantages and disadvantages. So let's start with the simplest approach. Let's talk about the naive solution. In here, we can use the built-in sort algorithm and C++ built-in sort algorithm runs in n log n. So overall, the time complexity of this approach will be n log n. And here I'm writing the sort function. It starts with beginning and ends. I made an interesting mistake. There's a typo. And as you can see, it's running and yeah, it's successful. So we've seen n log n approach, but we can do better than this. And here we create three variables, three integers, and we are going to use this to store the count of the zeros, ones, and twos, and we will shape the output vector by using these three variables. In here, if you understood the approach, you can implement it by yourself and come back to the video. So I didn't write the runtime complexity of this, but it is O(n). So we are doing two iterations. And here I created these three variables. I'm iterating through nums. And if the value is 0, increase A. If value is 1, increase B. And otherwise increase C. So here I got a little confused. I mean, you will see it. So first I create a for loop and it from 0 to A and increase it and nums I. So basically I'm changing every single element of nums. Here I plus GL. GL is the global location. That's the confusion that I have. So it's first 0 and now I try to increase it, but it is not necessary, because if you increase it then you will have lots of like increase. So in first it will 0 and then it will be 2. Instead of having this in the next, we should start from A. So I do this to get the A here. It is better. Global location becomes A, and then again from 0 to B, because we have B many ones, and yeah, we change the value in location, but it's not I, it's I plus global location. Global location is A in this case, and here global location increases by B because we did A and now we increase B, so we can start in the correct index. And yeah, now it will be 2 instead of 1. Let's try this code. Now I try this solution with the both examples, so example 1 and example 2. It is okay, and I submit the code. So now we will solve this question in just one iteration and using extra constant space. So the algorithm is pretty straightforward. We will just do one iteration, and in each iteration, for each value, we will put them into correct location. So not actually each of them. We will put 2's into correct location and 0's into correct location. While we are doing that, 1's will be automatically be in the correct location. So what is the correct location for 2's? We start from the back, and what is the correct location of 1's? We start from the beginning. If we do that, once, like I said, I write this in here, once will be in the correct location. I made a typo up there. It will be 0's, not 1's. And yeah, what will be the runtime complexity of this? Well, time will be O(n), because we are doing one iteration. Memory is O1, and number of passes, it will be just 1, because we do one pass. So let me start coding here. First I create 0 location and 2 location. So 2 location is n minus 1, and 0 location is 0, and n is the number of sizes here I defined afterwards. And now we need to iterate through the array. And if the numbers I equals to 0, then that means we need to put this into 0 location. So we will swap nums I with the nums 0 location, and then here I had some hard types to write. We decrease the minus, we will decrease I by 1, and I forgot to increase the 0 location, but I will add in the end. So some of you will be wondering why do we decrease I by 1? Because we don't know the thing that we put inside for that location. So we need to check that exact point, same point again. That's why we are decreasing I by 1 to check the same location again. Like I said, we swapped something, but we don't know what we put. And here I write, if it's 2, again I swap with 2 location and decrease the 2 location. So I increase 0 location and decrease the 2 location. And we always increase I if we are inside of this. But this code has some problems. If we try this code and run this, we will get some errors. So now I'm trying to run it, and you will see the results. It is wrong answer, and we get some random values. So please think about the solution first and come back here for the solution. So I want to iterate one example to make the problem more clear. So, but overall, the problem is about doing the same thing that we shouldn't do. So here I write the 0 location, 2 location, and the example 1 input. So first we're in the index 0, and we see it's 2, and then we swap it with the 2 location, and we decrease 2 location by 1 and increase I by 1 before the end of the iteration. So the nums becomes this 0, 0, 2, 1, 1, 4, and I becomes minus 1. So in the beginning of the iteration or the end of the very for loop, I becomes 0 again for the next iteration, and now I is 0, and 0 location we need to put into 0 location, and 0 location is also 0, so basically we swap it with itself and then decrease this I by 1 and 0 location by 1. And now we are doing the next iteration. So we're still in zeroth index, and now the zero location is 1, so we swap these two, but they're both 0, so basically we swap nothing. So we swap 0 with 0, index 0 and index 1, and the array didn't change. We increased ZL by 1, decreased I by 1, and in the beginning of the next iteration I will be 0 again, and now we are in the 0th index, and we swap it with the 0 location, which is 2. This is wrong. We shouldn't do this. So yeah, 2 will come to the front, 0 will go there, 0 and another 0, 1, 1, 2. So we swapped with the second index with we swap second index with the 0th index, and it goes like that. So as you can see, this is a very wrong solution. So to solve this, we need to understand the problem first, and now we understood the problem. This is the problem. 0 location or 2 location is out of bounds. To solve this, we can apply some logic, but again, we are trying to put an element into the correct location, but that element is already in the correct location, and that goes for 0 and 2, as you have seen in the example. To solve that, basically we need to check if the element is in the correct location. If it's in the correct location, don't do anything. How do we check this? 0 location. Oh wait, here I got confused again. Nums I. If nums I is 0, and then if I is smaller or equal than 0 location. So basically, if we have 0 and if it's in the correct location, if we have 2 and if that 2 is in the correct location, which is bigger than 2 location, in these cases we don't do anything, and this should solve our problem. Now let's try. I made a mistake here. It's nums, not num, and it's got accepted. Let's submit this, and yeah, it's a success. Thank you very much for watching. If you have any questions or comments about my solution, or if you want to propose a new solution, please mention them in the comments, and see you in the next video.